Good afternoon. Welcome to Build 2015. Wow. Welcome to Build 2015. I'm Reed Townsend. I'm a lead program manager on the Windows Input platform team. And today we'll be talking about the Input platform and how to take full advantage of it in your apps. That's our title. I've been asked to remind you to fill out a session evaluation. There are prizes, so please do that. And there'll be another slide at the end of the talk that has the QR code you can scan. We'll cover four broad areas today. The first is the Universal Windows Platform and what is the promise it makes to developers and how that relates to Input. We'll talk next about the Input platform at a high level and talk about the various layers of the platform stack and what's available to you. Then we'll jump into some code, we'll get our hands dirty, we'll look at some examples, and then we'll wrap up with some pointers to other interesting sessions and other resources for you. So what is the Universal Windows Platform, and what exactly is it promising developers? Well, there's two important aspects. The first aspect is that the same platform is available to you on all devices running Windows 10. And then, as was mentioned in the keynote this morning, the second important aspect is largely due to our Windows as a Service work, we're going to have hundreds of millions of machines out there running Win 10 that you can target. So put those two things together, and you have a huge addressable market that you can very easily target with your apps. So I really like this slide from the keynote. One of the things that's great and unique about Windows is the breadth of hardware we support. There's a huge number of form factors, devices that only run Windows, from little Internet of Things devices to tablets, phones, Surface Hub, holographic devices like HoloLens. But from an input point of view, that means that there's a lot of inputs you need to think about. There's touch on phones and tablets and PCs and Surface Hub. There's pen on many of those same devices. There's game controllers. There's holographic input. And we haven't even talked about mouse and keyboard. So how does the Input platform help you here? The Input platform's promise is similar to Universal Windows Platform's promise. And the same Input platform is available to you on all of these devices. But the corollary to that is there's a lot of different inputs that your app will be exposed to as it runs on that breadth of hardware. Our promise is that the Input platform makes it easy to handle all of these inputs and lets you build the app that you envision. I'll add, I think the apps that will do best on the store will be the apps that best handle that breadth of hardware that they'll end up running on. And it's an easy way to differentiate your app from others. So let's do a quick demo. Let's see the Universal platform in action here. So I will start actually with the desktop, and I'll launch OneNote here. This is the Universal App version of OneNote. The Office team's done a great job building universal apps. I think you saw earlier today the Excel and PowerPoint versions. This is the OneNote, and Input works as you'd expect here. I can use the mouse. I can create a new page in my notes. I can type with the keyboard, build demo 2015. This is text I entered on desktop. You can use touch. If I have a pen, like I do on my Surface, I can ink. I can draw a smiley face. So Input works very much as you'd expect here. But this is a universal app, so I can also run it on the phone. So I've got the same version of OneNote here on the phone. I don't think you need to see my to-do list. But you can see that it's synced to the page. We now have that page that we just created over here on the desktop. Touch works as you can expect. You can pan, you can zoom your content. The ink is rendering here. I can double tap some text, and I could enter text here. But I've also hooked up a Bluetooth mouse and keyboard. And let me move that text back. I hit tab a lot. So I can use the mouse, and I can select here on the phone and enter some new text. So I'm entering text on the phone. I'm using the mouse. So the Universal Windows Platform lets you run your app across all these devices. The Input platform is the same Input platform available in both places here. The OneNote guys didn't write any special code for desktop. They didn't write any special code for phone. It's the same code running. And as part of this work, we've brought a bunch of new inputs to devices that didn't have them before. And as you saw in this morning's keynote, adding a Bluetooth keyboard and mouse to a phone is the first step in participating in that continuum experience. So if I then took my phone and connected it to a display via HDMI or Miracast, I can get a PC-like experience, a desktop-like experience using just my phone. So what about Xbox? Some of you, as developers in the audience, may be thinking to yourself, I know how to write a tablet app, I know how to write a phone app, but what happens when that app goes to an Xbox? What do I do there? Or vice versa, I'm building a game, I know exactly what I want to do with a controller, but I don't know how that's going to translate when I bring it back to a PC or maybe something like a phone or a tablet. The Universal Windows Platform this fall will bring the Xbox Gamepad APIs to the platform and make them available for you across devices. So I think a lot of you have probably seen an Xbox One controller, and you've used it with an Xbox. But how many of you have seen a Xbox One controller on a desktop in a Universal app? So we took a really simple sample. I think many of you have seen this before. This is the DirectX first-person shooter sample. It's been around for a while. We converted it to be a Universal Windows app. It took us about 5 minutes. We added controller support, and suddenly you have an application that will work great on your Xbox, it'll work great on your PC. And it's really our universal platform that's going to make handling controller really easy in all your apps. Let's talk about the input platform. So the input platform has we typically think about it in 3 layers. The topmost layer is kind of what you get for free. Frameworks and controls have a bunch of built-in support, whether it's things like input events the frameworks generate for you, or controls, date picker, slider, text box, calendar. There's a bunch of new controls in Win 10 as well, but there's a bunch of built-in stuff that you get for free. The next layer is really, if you need more power and flexibility, maybe you're building some custom control, that's when you step down and use APIs like pointer, pointer device, gesture recognizer, things in that family that give you a lot more power and flexibility. And then finally, if you need ultimate power, you can go down to core input. This is about as close to the metal as you can get. We'll talk about this towards the end of the talk, but this is where you go if the other layers aren't giving you exactly the control power and flexibility you need. So we'll talk about each layer in turn. We'll start with frameworks and controls. The frameworks offer a bunch of controls, and the controls all have support for input built into them already. So you can use something like a button with touch, with pen, with mouse, with keyboard. All of this works as you'd expect. And if you stick to the built-in controls that the frameworks provide, your app's just going to work across that broad spectrum of hardware, whether you're running on a phone or on a Surface Hub. Your app will just work. So let's start looking at some code here. I'll pull Visual Studio up, and we'll do a quick example of what you get with the controls. OK. So if we run our sample here, I have a really simple sample. I'll show you the XAML in a second. It's just adding 3 basic controls to my app. We've got a button, we've got a slider, and we've got a text box. And I picked these because they each show something interesting about input. The button, I can use the mouse. All we've got it hooked up to do is change the background of the application. I can click on it with the mouse. I can use pen and tap on it. I can use touch and tap on it. And if it's got focus, I can use the keyboard and cycle through it. So all of these controls, right out of the box, already support the inputs that you're going to see across our broad spectrum of hardware. The next control here, that blue makes it a little hard to read things. Let's lighten it up. The next control here is a slider. And a slider is also a pretty simple control. You can see I move it, and it just shows me the value in this little call out. But when I interact with it with touch, the call out moves. Slider is a good way to demonstrate that we've thought about the interesting aspects of each input, and we've customized the controls to be optimized for those inputs. If we had the call out with the value in the same place that we do for mouse, you wouldn't be able to see it with your finger. Your finger is too large, it's opaque, you wouldn't see it. Another thing that's interesting about the slider is that it uses capture. So I can grab the thumb here, but I can also move my finger off and still interact with it. Part of the reason this works is the slider, when you successfully grab the thumb, sets capture and all future input goes to the thumb. We'll talk about that more in one of our later examples, but it's a helpful tool for you when you're building controls. And then finally, we've got a text box here. Text box is built on Scroll Viewer, and we'll talk more about Scroll Viewer in a second. It behaves as you'd expect with touch. We've got feedback when you get to the end of content. I can select text and type with the keyboard. I can use the pen in there, for example. But we've also, this is another control where we've done some interesting differences between the inputs. With mouse, you have the traditional mouse selection model. But if I use touch, for example, you get the grippers, and you can grab the grippers to change your selection. So there's a slightly different selection model for touch. So for each of our controls, we not only support the inputs that you can expect to see across all the devices in the broad Windows hardware spectrum, but we've thought about what the right behavior for all these controls is. So let's look at the XAML for this. The interesting bit of the XAML is these three lines. So we just have a button that we're putting in there. We have a slider control, and we have a text box. There's nothing particularly interesting we're doing here if we look at the backing C#, other than just spinning in a for loop and adding some text to the text box. There really isn't a lot we're doing. The button has some code to just randomly set a background color. But this is all functionality you get out of the box. We haven't written a bunch of code for pen, for example, to make it work behind the scenes. But speaking of pen, let's add ink support really quickly to our application. I'm going to uncomment some code here and add an ink canvas. So ink canvas is one of the new controls we're offering in Win 10. It adds ink to your XAML app. The canvas will expand to whatever its parent element is, so I've just put it in a grid here and given it a height and width so it doesn't take up the entire surface of the sample. And in our backing C#, let's uncomment some code. The default behavior of ink canvas is that it collects ink from pen, but I want it to also collect touch ink. And so I can set on the ink canvas's ink presenter the input device's types property. I can set it to capture not just pen, but also touch. So let's compile, run that, and we'll show you what you get with ink canvas. So we can go back to our control sample, and now we have an ink canvas at the bottom. I can use my pen, and I can ink in it, and you get beautiful ink here. I can use touch. I can ink with it as well. You can turn on mouse inking if you want to. So Ink Canvas gives you a lot of functionality out of the box. It's really easy to add to your application. There's features around beautifying the ink and cleaning it up, so it's not just raw points connected with straight lines. There's Reco features that you can get access to. It supports input from a variety of different input types like mouse and pen and touch. And we have a couple talks that'll go into much more depth about ink that you should see tomorrow. So let's go back to our deck here. So there's a lot of stuff you get for free with the frameworks, but sometimes you need more than what they give you. And there's sort of two classes of things that you should think about here. The first is there are controls that are customizable. And we'll talk about Scroll Viewer. Scroll Viewer is an important control, but it's nice as an example because it also offers a lot of customization. And we'll also talk about the input events and the gesture events that you can get from the frameworks and what you can do with those. So Scroll Viewer is an interesting control. We looked at the top apps on the store, and 80% of them use a Scroll Viewer, 80% of the XAML apps use a Scroll Viewer in their code somewhere, which is a really high number. And when you consider Scroll Viewer also powers a number of other controls like Grid View and List View and Flip View and Text Box, when you expand to that entire family of controls that either use or are powered by Scroll Viewer, the number jumps to 90% of the top XAML apps are using it somewhere in their code, which is huge. The remaining 10% are things like games or other apps that don't even use the XAML controls. So basically, all of the top XAML apps that are using the controls are using Scroll Viewer in one way, shape, or form. So it's definitely a powerful control. It's certainly popular. Part of the reason it's popular is panning is such a core part of our interaction language. If you're on a phone, you've got a small screen, you pan through content. A lot of our controls like Pivot and Hub are built on panning behaviors. So Scroll Viewer gets used in a lot of places. And at its heart, it just offers you a way to have a lot of content in a small space in your app and sort of pan through it, right? But you can also do other things. You can turn on support for zoom. You can turn inertia on or off. There are snap points, so you can, if you have inertia on and somebody pans with enough velocity to generate inertia, snap points will ensure that you end at a logical boundary in content. There's other things like rails and snap points for zoom and other things like that that you can turn on as well. So let's look at a little bit of code here in a sample using Scroll Viewer. Oops. So we have a real simple sample here. There's a bunch of toggles and a drop-down that control some behaviors behind the scenes. But the Scroll Viewer itself is this set of rectangles. And we've just stuffed a stack panel in the Scroll Viewer, and the stack panel has a bunch of recs, and the recs have different colors. So I can pan through these. By default, you can see that you get inertia and panning for free. I haven't touched anything here yet. Notice also the scroll bar on the side. The scroll bar with touch, since panning is such an easy thing to do with touch, we don't really expect you to use the scroll bar. The scroll bar is really more of just a visual telling you where you are in your content. But if I use mouse and bring it over here, you'll see that we get a traditional scroll bar. This is another example of how we sort of optimize the controls for each of the inputs you might be interacting with them. I can do things here like turn off inertia. So if I turn off inertia, obviously it doesn't have inertia when I pan. I can turn on zoom, and you can do something like zoom out on the stack panel and see all our recs here. We can zoom way back in if we want. All of this is powered by the great pan and zoom behavior that you get from direct manipulation behind the scenes. The frameworks take care of this for you. So we can also turn on snap points. So when I pan the content, it doesn't necessarily snap to any content boundary. But if I turn on optional snap points, when I pan, you'll see that we adjust the inertia curve to ensure that you always land right on the edge of, well, most of the time you land on the edge of a content boundary. The optional ones don't force you to. If it would be too much of a change, like for example, when I pan like that, it's not going to snap me to anything. But if we have a little more velocity, it makes it pretty easy to just tweak the curve a little bit and ensure you end on a logical content boundary. If you move to something like mandatory snap points, I can't leave the stack panel here and have it not snap to a content boundary. So mandatory will force you to snap to something. This is really good for a control like flip view. Like if you have a control where you're flipping through photos, you probably don't want to leave the user in a space where they've got half of one photo on one side and half on another. That would be a great place to use mandatory snap points. But if you're building something like Excel or maybe a list view, maybe you've got a list of emails, maybe it's not quite as important that you always snap to a content boundary. You could turn on optional snap points, and then it would look very natural for the user when it does snap. So let's look at the code here. Where's Scroll Viewer? So the XAML for this is real simple, but we'll just look at the code. So when we toggle inertia, all we're doing behind the scenes with the Scroll Viewer is toggling this property. Is scroll inertia enabled? Real simple to turn inertia on and off in your Scroll Viewer. There's also a zoom inertia. So maybe you have a map and it's pannable in 2 dimensions. You can zoom on it as well. Maybe you want inertia for zoom there and let users, maybe on smaller devices where it's kind of a pain to sort of repeatedly zoom, you could turn on inertia to make it easier to make large changes in zoom factor. When we're zooming, the toggle that turned it on and off just changes the zoom mode property. So there's this enum zoom mode. You can set it to enabled, disabled, really straightforward. Snap points. We have a little switch statement down here that looks at whatever the value of the dropdown is and sets the vertical snap point type. There's a number of properties for snap points. There's a whole set of properties for horizontal snap points. There's a whole set of properties for vertical snap points. You can do things like set the type. There's mandatory. There's optional. You can turn them off. There are properties for alignment. I think you probably noticed in the sample it was always snapping to the top of the recs. You can have it snap to the bottom of your elements or the center of your elements if you want. So you can change the alignment. There's also zoom snap points that you can control. And there's other things you can set in Scroll Viewer as well. There's rails. There's other behaviors that are customizable. Rails are useful for cases. Maybe you've got some 2D pannable content, but Most of the time, users pan vertically with it, and you want to clean up sort of sloppy vertical pans into something that really is axis aligned. That's a great place to turn on Rails. So Scroll Viewer is really customizable, and it gives you a lot of options. And it's really easy to use. It's really just changing a couple properties on it, and then sticking your content in it, and you get that really great zoom and pan experience that you expect with Windows. Other than customizing customizing controls, the other thing that you can do with the frameworks pretty easily is respond to input events. And there's a couple classes of these. There's raw pointer events. I think a lot of you are familiar with pointer. They let you do things like tell if a pointer comes down on a UI element in XAML or an HTML element in a web app. And you could use maybe you're building a button, some custom control that has button-like feedback. You could use the pointer down and up events to simulate press feedback on the button. There's also enter and exit events that would let you simulate things like hover. So if you want to bring a mouse or a pen over a control and have it have some hover feedback, maybe a tooltip pops up, you can do that with the pointer events. There's also gesture events, and XAML provides some relatively rich ones. Web apps and HTML provide a pretty standard set too. And with these, you can respond to a lot of the standard gestures that you see in Windows. Tap, double tap. We have a right-click event that we'll talk about in a second. So let's look at a couple of these in action. I'll run the sample again and show you our code here. So again, another super simple sample from the XAML point of view. We've got 4 recs, and each of them handles different events. So this topmost rec listens for pointer pressed and released events, and we're just changing the color on it. Again, these events are fired for all the inputs that we care about. So touch, mouse, I can use pen here and trigger all the same events. Still using the pen, I can hover over this control, and you can see that I get enter and exit effects. I get the same thing with the mouse. You can tap or double tap on this one, and we're listening to some basic gesture events. And then this bottom control listens to the right tap event. We should talk about right tap. Right tap's kind of a meta event. It brings together all the things that are logically right click across all of the inputs. So for a mouse, a right click is a right click. For something like press and hold, for something like touch, it's press and hold. Pen supports 2 ways of generating right clicks. You can press and hold with the pen, just like you did with touch, or you can hold the barrel button and tap if your pen has a barrel button. So there's a lot of ways to get right clicks, but we wanted to make it easy for you as a developer to just have a single handler for these things, and the input subsystem behind the scenes takes care of recognizing what the input was, what the data flowing from that input was, and deciding if it's a right click, and it just fires the event for you. So very simple. Let's look at the code here. So we set up our sample with, let's see if I can get rid of that black line. Okay. We set up our sample with a couple event handlers. The first pair are the pressed and released handlers that you saw in that first box. So when a pointer comes down or up, those events get triggered. The next pair are enter and exit. When a pointer comes over some content, you'll see these. For the gesture handlers, we're listening to tap, double tap, right tap, which is that meta event that sort of rolls all the right-click events together, and holding. We'll talk about holding in a second. Most of the handlers in the sample are real simple. They're just changing the background color of the rect that they were in. So not much to talk about there. But when we get down to holding, it gets a little more interesting. Holding is an event that has a couple different states. So if you're doing a press and hold with touch, there's basically 3 things that can happen. Your finger comes down. If you wait long enough, you will eventually get a holding start. We don't want slow taps or if the user just brushes the screen to start triggering press and holds. So there's some time threshold that you have to pass before we'll allow you to be in a press and hold state. Once you've crossed the holding state, then one of 2 things can happen. You can either successfully complete the press and hold, or you could drag away, and then the hold gets canceled. So in the hold cancel case, you'd see a hold cancel event come in. The holding state would be hold canceled. Or in the case where they complete it successfully, holding state is completed. And if we go back to the app and I press and hold, you can see that after I press and hold on it, we get the hold start event, and we update the text and the color for holding. And if I drag away, we get a hold canceled, and you didn't get press and hold. If I do successfully press and hold with touch, you'll see that it generates both a hold complete and a right tapped event immediately afterwards. And the right tap comes in so fast you can't see the text saying that hold completed there. So handling these basic input events is really simple as well. So what happens when you need a little more power and flexibility? If what's built into the frameworks isn't what you need, where do you go? So this is the sort of second layer in the platform stack that we want to talk about. These are our sort of lower level APIs that give you more control over the raw data and gesture detection and other things like that. So these are really good for building custom controls or experiences that go beyond what you get for free. So the first thing to talk about are the pointer APIs. The pointer APIs, I think most of you have used these before. They abstract touch and pen and mouse together, all of our pointing types, maybe future inputs, into one coherent API surface. That API surface makes it really easy for you to get common properties that all of these pointer types share. Things like the position of a pointer, the ID of a pointer, a handle back to the device, the type of it. But you can also, if you want to, you can go and grab off the property bag on the pointer. You can get input-specific type data. So pens have things like pressure. You can figure out how hard the user's pressing. Something like touch has a contact rect. We know the bounding box around the fingers, and you can make some decisions based on the contact rect. A mouse has buttons and wheel state and things like that. So pointer's a really interesting API. We'll show you this. I don't know how many of you follow web standard discussions, but the W3C just ratified a web version of Pointer as a new standard. So we're super excited about that. We worked with Firefox, Google, a bunch of folks in the web community to iterate on the standard and make it better over the last year and a half or so. And just 2 months ago, it was accepted as a standard. So we're very excited about that. Firefox has an implementation right now. Google's working on implementation. Obviously, IE and Edge both have implementations of the new Pointer standard too. So you can use it in web apps or your web pages directly. So let's look at the code. And let's see Pointer's expression in Universal Apps. So let me switch to the machine, sorry. Our sample here does a couple things. So we set up a couple dictionaries basically to track the contacts and let me show you the sample before I talk about the code. So we've built a sample here that does a couple things. When I put any pointer down, it basically gives us debug spew about the pointer. You can see in the black section at the top a bunch of common data. If I put a touch down, you can see that the common data remains the same. We're showing you ID, position, contact, those other common properties. But then in different colors below, you can see some input type specific data. So if I go back to mouse, it shows us the button state. And right now I'm holding down the left button. If I hold down the right button, we can see that here. With something like touch, you can see that the IDs for all of these contacts are different, and we can track all of these things. We talked before about contact rect. So I'm going to put my thumb down, and if my thumb is mostly perpendicular to the screen, you can see that the rect is more or less square, right? It's sort of 90 by 70. But if I start flattening my thumb out, you can see, you should see, that the the height gets larger. So some touch hardware detects contact rect size, some doesn't. One of the nice things about the Pointer APIs too is you can tell if the hardware is giving you that information very easily. You can query it and say, hey, do you support contact rect? And you can find out. For things like pen, we have a bunch of button states, so I can press the barrel button, I can press the eraser, and I can work with pressure here, so I can max out the pressure or press very, very lightly. So if you want to get to that rich input-specific data, like maybe you're OneNote, and you want to do something special with pen where you vary the thickness of your ink, you can get to that data and make those kinds of decisions in your app. So now let's look at the code. The XAML is real simple. It's just a blank page. Behind the scenes, we have a couple dictionaries for tracking those UI pop-ups that we create. But the real magic is listening to these pointer events. So we set up handlers for pointer pressed, moved, released, and wheel changes. And then the handlers for these do a little bit of work like tracking the point, but they really just create those property pop-ups that you saw following the different events. So for pointer pressed, we create the property pop-up here. For pointer move, we update it here. And for pointer released, we clean up after ourselves. So what does it look like getting those property pop-ups? Well, we do two things. We, one, get the common properties, and then we also check if there's device-specific properties for that input type. The common properties are relatively easy to get. These are all just sort of first-class properties hanging off the pointer point. There's things like pointer ID. There's a point that represents the position. You can get the X and Y off it. You can get whether it's in contact or not. You can check the type. You can get a handle back to the pointer device and do things with the device. So there's a number of things that all pointers share, and we're pulling some of out here. And then we look at the type of the pointer. So we check, is it mouse, is it pen, is it touch? And then we go and look for some properties specific to those. So in mouse, for example, the first thing we do is get the property bag. So each pointer point has a properties property that is a property bag, and it has all the rich type-specific data in it. So we grab that property bag, and then from it, we can get things like the button state, whether somebody's generating a mouse wheel. If we look at touch, you can see we can get things like the contact rex, the contact height. There's sort of two models for working with this stuff. One is you can ask the hardware, hey, do you support pressure? Because theoretically, a touch device could support pressure. It doesn't have to be a pen. So you could ask the hardware and say, do you support pressure or whatever property? Alternatively, all of these properties sort of have smart defaults too. And you can just use pressure directly in your application. And if it's an input that doesn't support it, you'll get some default value like a median pressure. Or if you want to use contact rect in your app, you can just code against it. And the contact rect will be 0 for hardware that doesn't support it. And it will have some non-zero value for hardware that does support it. So a lot of these properties are smart behind the scenes and make it easy so there's not a bunch of if this property exists, then my hardware do X, Y, Z. So pointer's relatively simple to work with. Let's talk about gestures. Pointer's good for things like building a paint app, although you'd probably want to use our inking APIs for that. Maybe you're building a custom control. If you were rebuilding button for some reason, you'd use raw pointer events. But in a lot of cases, you want gestures, right? If you were trying to rebuild something like Scroll Viewer, you'd want to detect pans, you'd want to detect zooms. Maybe you have some manipulable object in your application, like a pane that somebody can drag down from the edge of the application or something like that. Those are good places to use things like Gesture Recognizer. And Gesture Recognizer provides you a common reusable way of getting to the system's gesture detection. And it detects a number of things like taps and holds and manipulations and other gestures. But it gives you the same inertia curves that you see elsewhere in the system. It has the same thresholds for tap and double tap. It knows how to generate a right tapped event from all the different inputs. So if you want to handle right click, you don't need to build 4 different gesture detection things for the 2 ways pen does it, the way touch does it, the way mouse does it. So there's a lot of built-in system functionality there that's reusable for you. There's a couple other cases where it makes a lot of sense to use it. Maybe you're not using a framework. Maybe you're building a game, or your app is built directly on top of Core Window, and you're using DirectX to do your rendering. Those are cases where you have to go to Gesture Recognizer. Another more complex case might be something like, I have a bunch of gesture recognizers, and they're all configured differently, and I want to pass input to all of them, see what the outputs look like, and then make some decision based on what that output looks like. That might be a case where you have to go to Gesture Recognizer. So let's take a look at some of the code. And actually, before we look at the code, let's talk about what XAML gives you here. So we'll start with a XAML sample. This is real simple. We've got some UI that toggles things, and then basically we have a rect that we can manipulate here. So we've set it up to allow translation and rotation. It's got some inertia. I can throw it off screen. And we've also done some things to control how gesture detection works here. We can constrain the element to only move on one axis. You can see here we've locked it to the x-axis. I can lock it to the y-axis as well, or have it be sort of 2D manipulable. And this is all built on stuff that XAML gives you today. So let's look at the code for that, and then we'll take a look at Gesture Recognizer and how to build the same experience with that. So remember when we were talking about the input events available to you? In something like XAML, you can listen to more than just tap and double tap and right click that we showed in the first example. You can listen to richer gesture events like manipulations. And so that's what we've hooked up here. The XAML is simple, it's just a rect, and we're going to set a couple handlers on it. So we do some initialization, we set up our transforms, but then we go and listen to 4 different manipulation events. So manipulation started fires when you start a pan or start a zoom or a rotate or something like that. Manipulation delta fires during the progression of your event. So while the user's panning, you're going to get a started and then a bunch of deltas sort of tracking how far they've moved. You get manipulation completed when all the fingers come up and the manipulation ends. And if inertia's on, you can also see a manipulation inertia starting event that tells you that inertia's begun. And then manipulate me here is just the name of our rect in the sample. UI elements in XAML have a manipulation mode property on them. And here we're configuring it to allow for translation in the x-axis, translation in the y-axis, and rotation. And then we set up inertia for both of these things. So we just OR all those together and stick it in this manipulation mode. And now you will start getting manipulation events when you interact with that UI element. So relatively simple. The transform stuff that we set up, we initially set it to the identity transform. But as we listen to those manipulation events, we'll be updating the transform, the render transform on that rect, and it'll start showing up and handling input in different spots based on the transform. So manipulation started. We're just changing the color of the rect to let you know you're interacting with it. If you remember the sample, it turns blue when you grab it. But a lot of the real work happens in manipulation delta. And so the first thing we do is we save the old transform, because what we get in manipulation delta is the new components for translation, scale changes, and rotation changes. It's not a cumulative one. There is a cumulative event that you can get to, but we're just handling deltas here. And so the first order of business is to calculate the center of that interaction. If we go back to the sample for a second, I don't always want to just rotate around the center of the rect. Sometimes I want to rotate around a point. Like if I grab a corner here, I want to be able to have that sort of natural interaction with my element and rotate around a point. I'm rotating around this corner and not the center of the element. So we figure out what the center of the manipulation event that's coming to us is. And we save that. And then we take the delta coming off the event and apply it to our rotation component of our transform. And then we take the x and y translation events, the information in them, and apply them to the x and y translation in our delta transform. This then gets applied to the rect, and suddenly XAML will now render it in its new position. When inertia starts and when the manipulation completes, we just change the color again. So real simple handlers there. So the meat of what's happening here in XAML is pretty straightforward. You set manipulation mode on a UI element that you want to be able to interact with, whether it's that rect that we're moving around, or maybe you have a pane that you want to pull down. You would just set up Y translation or something like that. And then you add some event handlers, you start getting your events, and you can calculate a new transform to apply to that element. If we want to look at how we did things like lock to a specific axis, we're just XORing out, translation in the y-axis or the x-axis. So if I want to lock it to the horizontal axis, we XOR out translation in y. Really straightforward. You can just change the manipulation mode. For inertia, we just turn off the. Scroll over so you can see this. We turn off the translation inertia and the rotation inertia. Again, just manipulating the manipulation mode property. So very straightforward to do this. Now, let's look at Gesture Recognizer. So we've rebuilt the same sample with Gesture Recognizer to highlight how, if you are using Gesture Recognizer, some of the differences from doing this in a framework. So it behaves the same way. You can translate, you can rotate it, we can lock it to axes. But the code's a little bit different. And the main thing that's different about the code is that The model for gesture recognizer is that you receive raw pointer events, and then you take those pointer events and you shovel them in the gesture recognizer, and it coughs out events for you. You'll see that the manipulation events that gesture recognizer generates are very similar to what you get from XAML. The pointer events will be obviously recognizable. You configure gesture recognizer the same way. The main difference from something like the XAML sample we showed you is that you're manually feeding the gesture recognizer. Now that gives you a lot of power too. You could have a bunch of gesture recognizers and feed them all from the same input, or you could decide which inputs go to gesture recognizer. Maybe you don't want to manipulate the rect with with pen data, and you could look at the type of the pointer data and choose to feed it or not to gesture recognizer. So having access to the component gives you more flexibility. So we set up the sample the same way. The only new thing is that we're creating a windows.ui.input gesture recognizer. And we have a little helper class down here, manipulation input processor, that we'll show you in a second. The code to set our transforms and lock to these axes is pretty much the same. So let's look at how we're setting up this helper class, manipulation input processor. So we hand in a couple things. We hand in the gesture recognizer, we hand in the element that we want to manipulate, and then we hand in something that's our frame of reference, which in this case is sort of the parentmost element. We set up gesture recognizer and generate some settings. If we go look at what we're doing with gesture settings here, you'll see that it looks a lot like the XAML. There we go. It looks a lot like the XAML. So we're setting X translation, Y translation, rotation, and inertia on both of these things, and we stick it in the gesture settings property. So you configure it the same way you configure XAML's manipulations. And then if we go back, the main difference is we're now listening to some pointer events. So we listen to the 4 pressed, moved, released, and cancel. And we set up manipulation handlers here, like we did in the previous sample. Again, some transform setup. That's our setting setup. And in our pointer handlers, so when somebody puts their finger down on that rect, we're going to start getting pointer events on it. We capture, like we were doing in like the slider does behind the scenes. So if your finger starts on the rect, and maybe due to how you're rotating it, or maybe you've got scale translations turned on, even if your finger comes slightly off the element, we'll still send the input to that element. So we set capture when you come down on it. And then we have these process events on gesture recognizer. So you can see here we call process down, and you pass in that pointer down to gesture recognizer. Similarly, for moved, we pass in a move. For released and cancel, we say process and up, and we release capture. In the case that a pointer was canceled, we tell the gesture recognizer just to complete what it's doing, reset itself, and call release on the pointer capture below. You get pointer cancel pretty rarely. You get pointer cancel pretty rarely. It's used for cases where the device unexpectedly goes away. Maybe you had like an external pen tablet and you unplug it. If you were in the middle of a stroke, you'd get a pointer cancel event. So we've gotten as far as getting our raw data on our rect. We're getting that pointer data, and we've shoveled into gesture recognizer. Now gesture recognizer is working behind the scenes, and it figures out what gestures you're seeing. So that's when you start getting these manipulation events. So much like the previous sample, in manipulation started and in the inertia and complete, we're just changing the color. And then in manipulation updated, which is like XAML's manipulation delta event, we're doing a couple things. We're setting the center again, because we still want to be able to rotate around a point. We're setting up our transform that has the delta in rotation, the delta in translation in both X and Y. And then that just gets applied to the element. We've already associated delta transform with the element. And then XAML will re-render it for you. So relatively straightforward. When we do something like lock to one of the particular axes, it works the same way. You can just XOR out whatever that specific gesture setting is, right? So when we lock to the X-axis, we're just XORing out translate Y. So gesture recognizer works a lot like the XAML manipulation element or events that you get. The main difference is that you're responsible for creating these things and for handling the raw pointer data and choosing how you feed it to gesture recognizer. XAML does a lot of that on your behalf, but if you want to have more control over it, you can use gesture recognizer. Let's say your app is super complicated. Maybe you're doing a billion things on your UI thread, or maybe you're making some audio app and you need the absolute lowest input latency possible. That's when you want to use core input. So now we're at the sort of bottom layer of our API surface, our stack. Core input gives you your input on another thread. It lets you not be blocked by the UI thread and receive input on some dedicated thread of your own. The way you get a core input is with a swap chain panel. Swap chain panel is a XAML element. It is a really powerful element, but it also asks a lot from developers. You get complete control over your input and get it on your own thread that you can do anything with. On the output side, though, you need to render with DirectX. So it's a big step up on the output side in terms of what Swap Chain Panel asks from you. And you're responsible for everything in your Swap Chain Panel. You also need to now hit test. And so we'll show you a sample that recreates the last two that we showed you, but uses core input and Swap Chain Panels behind the scenes. We're also, I should say, using Win2D here. This isn't a talk about rendering, so we're not going to show you 2,000 lines of DirectX code. Win2D is a new API that gives you a universal app wrapper around some of the things like direct write, direct 2D, a lot of the 2D functionality in DirectX. Win2D wraps it up and makes it callable from C# and provides simplified handlers for things like swap chain panel. They've got some other controls too. So Win2D is really good. There's a talk on it too that I think Simon Tao is giving at this build. So we're using that to help on our rendering, but we'll show you all of the input code. So we've done two things here. We have the same rect that we had before from our XAML manipulations and gesture recognizer sample, and we have another one that's hooked up to core input. And we can interact with both of these guys. But when I start blocking the UI thread, you'll see that there's a very different behavior. So we're simulating a very busy app that's doing a ton of stuff, but you still want to be able to interact with it. And all we're doing is we're making the UI thread sleep for about 100 milliseconds before it gets to process input again. But there are apps that see this kind of behavior in the real world, and you want to avoid this in those situations. So let's show you how you take advantage of core input and get your own thread for input handling. So we've got a little bit of setup here for the rect that we're drawing, just some constants up front. We have some helpers that we'll use for calculating our transforms. And then this is where it gets a little more interesting. So we create a couple things here in this section. Well, we define a couple things here in this section that are interesting to us. First is a swap chain. You need a swap chain for a swap chain panel. Canvas swap chain is the Win2D wrapper around the DirectX swap chain class. We also create a core independent input source. We call this core input. This is the thread that will give you your dedicated input processing. We also create a gesture recognizer that we'll be using on that core input thread to do all our gesture detection. I've got a dispatch timer that's just on the UI thread. We're going to use this to block the UI thread. And then we have that manipulation input processor, which was our helper from the previous sample, that just creates the gesture recognizer rect and handles it with gesture recognizer. So we set up our canvas, and let's talk about how we set up the swap chain panel. We create a canvas swap chain, which again is that Win2D wrapper around DX swap chain. You hand it a canvas device, and then you hand it the number of pixels wide and tall you want it to be. In this case, we're using the entire window. And then you hand your pixel density. So we go and figure out what the logical DPI for the application is and hand it. Since we're not resizing our app in the sample, we're not getting size events. If you were doing this for real in your application, you'd want to handle a window size event off core window and recreate your swap chain with the new size. Or if there was a DPI event, for example, if a user changed the system's DPI, you'd want to handle that too. So we're simplifying here for the purposes of the demo. And then we just take the swap chain and stick it in our Canvas swap chain panel. Canvas swap chain panel is the Win2D wrapper around the XAML swap chain panel. Makes it a little easier to use. And then we draw canvas. The very next thing that we were doing in our setup is initializing input. And so we can go look at this. And this is where we actually create the core input and set up some of our handlers. So we create in this line a sort of anonymous async action that we're going to run on a thread from the thread pool. And the very first thing that it does is it asks the swap chain panel for create core independent input source. There's just a static factory method on the swap chain panel that coughs up a thread for you and starts delivering input on it. So now our core input, which if you remember was basically a thread for us, now we'll start receiving input events. And we do a couple things there. We set up 3 pointer events on it. So we're listening to pressed, move, and release events on that thread. We create our gesture recognizer on this thread. Gesture recognizer has thread affinity. If you create it on your UI thread, but then start feeding it from another thread, you're going to run into problems. So we create our gesture recognizer on the same thread that we're going to be feeding it input. We configure it, again, just the same way as before. So this, the way we set gesture settings is exactly like we were doing it before. And then we set up the same manipulation handlers from gesture recognizer that we cared about before. And then we go kick the thread and say, hey, start processing events. So as soon as we call this, we'll start getting input events on that thread, and away we go. And that's really all we had to do to set up core input and start getting the events we want and start handing them to the gesture recognizer. The next thing that happened in our initialization was we set up our render thread. So we're just doing this very quickly here. Again, we asked the thread pool to create an async action for us. And all this is going to do is draw the canvas 60 times a second. And when we look at draw canvas, this is where you see some of the power of Win2D. It makes it really easy to draw simple 2D things. So like our rectangle, we just create a drawing session off the swap chain. We apply our transform that we've been calculating, or that we'll show you how we're calculating in our manipulation delta handlers. Much like we were calculating the transform for either the XAML or the gesture recognizer sample, we'll calculate the same transform. This time we apply it to our drawing session, and then we just call fill rect in that drawing session and tell the swap chain to present. And we'll just call that 60 times a second. Now, one of the things that you've probably guessed you need to do is because you're getting input on that entire swap chain, and in our sample, if you remember, the swap chain is the entire background. I need to figure out if I'm interacting with the background or if I'm interacting with my rect here that's hooked up to the swap chain. And so we have this little helper that hit tests for us and figures out whether that pointer down is actually on an element that we care about and want to interact with or not. So the math here is somewhat straightforward. We invert the transform that we have on our rect and apply that inverted matrix to the point to get everybody in the same coordinate space. And then we just do a simple rect intersection test and figure out whether that finger came down in the rectangle that we're manipulating or not. So for pointer events, this functions a lot like you saw in the previous sample. We hand gesture recognizer the data. Remember, we're just shoveling raw pointer data into our configured gesture recognizer. So we call process down when we get down events. We call process move when we get updates from our raw pointer data. And we call process up when fingers come up. Gesture recognizer takes care of all the detection behind the scenes for us and then starts calling the manipulation events. So these are the same manipulation events we saw in the gesture recognizer sample, and we're doing very similar things here. If we look at the updated one, we're just calculating a delta transform again, and then we just save it in this rect transform variable, which we use on our render thread and apply to the drawing session. So this is how, when you start rotating the rect or start translating it, we're just calculating this new transform for where the rect should be, and then the render thread takes care of the rest. So core input functions a lot like how you'd use gesture recognizer. You configure gesture recognizer the same way, you feed it the same way, you handle the events the same way. The big differences are you're going to be getting input data for your entire element that is your swap chain panel, and you probably need to do a little bit of extra hit testing there. If you had more things that you could interact with, you would have to hit test each of them, figure out which gesture recognizer associated with those interactable elements you want to start feeding the pointer data to. So core input really lets you get down as close to the metal as you can. It gives you a lot more control, a lot more power, and a lot more flexibility. So there's a couple other APIs to be aware of. Ink APIs. We have a bunch of stuff. We've only not even scratched the surface in what we're offering for Ink in Windows 10. We have 2 talks tomorrow. There's sort of a 200-level talk that will give you an overview of Direct Ink, and there's a 400-level talk that dives way deep into the details in the code. Gamepad. I think you saw in the keynote this morning, Terry showed using the gamepad and being able to interact with controls in, I think it was a video app. So there's 2 flavors of what you'll get with Gamepad. One, Gamepad will uphold our promise of all of the built-in controls supporting the various inputs. So you'll get free support for being able to use the D-pad on the gamepad to navigate between controls. You can hit the A button to select things like that. You'll also get the Xbox raw gamepad APIs. So if you want to get analog thumbstick data or trigger data or all the button state, things like that, you can get that in the Universal Windows platform. We have great text APIs coming in Win 10. There's the core text APIs that let you build word processing apps, note-taking apps, things like that. There's a bunch of device and form factor APIs. We didn't talk so much about them today, but there's pointer device, which you get with any pointer event. You can walk back to the device and find out its type and other things. There's some capability APIs that let you check for the presence of different inputs. So if you want to know if mouse and keyboard are attached, you can do that. If you want to know if pen or touch are attached, you can do that. There's also some very simple APIs around Continuum that tell you what state you're in. Are you in a more tablet state? Are you in a more desktop state? There's visual feedback APIs. You can control mouse cursors. You can turn off those touch visuals in your app if you want to do something different. And then finally, you should be aware of the touch targeting APIs. If you are building a custom control, then you may want to use the touch targeting APIs. XAML and the frameworks know what the interactable elements are. So for example, a button in XAML, it tells the system, hey, there's a button here, and it has these bounds. The system then can do things like map sloppy touches onto that button. If you clicked just off it and missed it by a couple pixels, well, the user was probably intending to interact with that button. The system cleans that up for you automatically. If you want the system to do that with your custom controls, you can use our targeting APIs and expose very similar data to the system to help it make those decisions. So one final thought before we wrap up. It's not just about the code. It's about how users interact with your app and the sort of UI design too. You should think about things, particularly for touch, what the size of your controls are. We have recommended sizes to ensure that users can interact with tiny targets. There's guidance around white space. If you want to know whether you should have controls on the edge of your app or not. This and more is covered in Jeff Arnold's talk. There's a nice design talk that talks about how to not only make your apps beautiful, but make them really usable for users. That's a good segue into related sessions. We talked about the 2 ink sessions. 681 is the sort of 200-level introducing Direct Ink overview. You should definitely attend that one. 705 is our 400-level deep dive into the inking platform. That's another great talk. There's a speech platform talk. We'll go into depth about using the speech platform. 679 is a XAML talk about adaptive UI. So you remember that broad spectrum of Windows hardware, and we talked about how you should be aware of the different inputs and how you use them across those devices and form factors. If you're writing an app that's going to work on phones and on a Surface Hub, you should think about how changes in display size affect your app too. XAML has a bunch of controls and built-in functionality around adaptive UI that will help you sort of transition across different display sizes, and 679 will talk about all that. 703 is a talk about Continuum and will help answer questions about what developers need to think about when they're building apps and want to be aware of the Continuum experience. And then finally, 658 is the design talk I just mentioned. This will help you build great apps that users love. We have a ton of samples. Pretty much everything I showed you today has a sample in one shape or form up on GitHub today. We will take all the code that we put together for this talk and get it cleaned up and get it up on GitHub too. So we covered a lot today. I think the biggest takeaway is the Universal Windows platform is going to drop hundreds of millions of targetable, addressable systems in your lap, and the platform makes it really easy for you to build apps that run on all those devices. The apps that do best will be the ones that do well across the broad set of form factors that Windows runs on. And our promise to you is that our platform is going to make it easy for you to handle input on all of those devices. So go forward, build great apps. Hopefully now you have all the tools to build whatever you can envision. Thank you. I think we have 2 minutes for questions. So if there are questions, come up to the mics. But otherwise, I will be at the speakers lounge or the insider lounge for the next hour or so, and happy to answer questions there too. can you use the mic so the video can capture it?
So if I wanted to use, like, capture a gesture, like I'm swiping over a particular control and capture that, or if I draw a circle and I want to be able to tell the difference between the two of those in code, would I use something like that to do it? How would I do that?
Yeah, that's a great question. It's a great question. So something like a circle isn't a gesture that the system detects natively. It's not part of our core interaction language. We don't use sort of a circle gesture for anything. You could, though, detect things like swipes and then have your own custom detection that detects a circle and makes some decision about those. Like, that's a great place where you could use a gesture recognizer, feed it some data, and see if you got something like a translation or a pan kind of gesture, and then also be feeding the data to your own gesture recognizer that looks for something that's like a circle, and then decide what you want to do based on that.
That'd be a cool ink recognizer. So I had a question. So on the you added like the Gravity Well stuff's new, isn't it? The Snap stuff, is that new? Or has that been?
The snap points?
Yeah.
They've been there for a little while. I think they were exposed in Win 8.
Yeah, so it'd be nice if you had that, whatever you're calling there, and under the hood, you're tuning gesture recognizer, I'm guessing.
Mm-hmm.
It'd be nice if you're doing the core input thing, you can't use XAML, and you're using DirectX. It'd be nice to have whatever those subroutines you were using exposed so you can use them yourself.
Yeah, that's good feedback. You are correct that they're not exposed today on Gesture Recognizer. You could build those experiences yourself.
Yeah.
But yeah, that's interesting feedback. They are exposed at the direct manipulation layer. And in something like XAML that shows up in Scroll Viewer or as CSS properties in a web app. But if you're using Gesture Recognizer, we don't have the snap points plugged in today.
Yeah.
We should think about that. Cool. Thanks, everybody. I'll see you at the speaker lounge.